There we go. So we are live. Welcome everyone to our webinar today. My name is Rebecca and I'm a community developer with the Malt team. That means I'm responsible for creating fun and engaging events, webinars, and lots of different content for our freelance community here in Malt in the DACH region, so Germany, Austria, and Switzerland. Welcome. Welcome. Feel free to use the chat at any time to ask questions, leave comments, maybe some words of motivation for us or for Dr. Cedric Scherer, who's with us today. Below, you'll also see a questions function. So if you do have any questions, you can either, like I said, pop them into the chat or use the questions function on the side, and I'll be monitoring the chat during the webinar today, and we will have time at the end to answer any questions. So with that being said, we'll just look at the agenda. So we'll share some updates, and I'll give a little bit of background to Malt for those of you who don't know Malt yet. Then we'll have our workshop with Dr. Cedric Scherer, who has joined us today. And then we'll have some time for question and answer at the end. So make sure you can send the questions in during the webinar, and I'll just be collecting them and I'll read them out at the end. So who or what is Malt? Malt is the leading European freelancer marketplace. We have around 390,000 freelancers on the website, and that number continues to grow quite rapidly from month to month. 50,000 clients trust in Malt services. Malt has received 112 million euros in funding so far from some of the investors below. And the company was founded 8 years ago in France, in Paris, and it's been in Germany since 2019. But you can find us in many other European countries, such as France, Spain, Belgium, Netherlands, and the UK soon as well. You might recognize the one or other client over here, but these are just some of the clients that are using Malt. We'll hop right into it, but if you have any other questions about Malt, feel free to put them into the chat or feel free to contact me. My email is here. We have lots of other cool events planned, webinars planned for you in the upcoming weeks. So if you're not already registered on the platform or on the website, then feel free to do so. It's free of charge. Also, feel free to register or subscribe to our newsletter because that's where you'll hear first about all of the exciting things we have planned for you. And with that being said, I will hand it over to Dr. Cedric Scherer, who has a very, I heard, engaging presentation for us today.
Oh, now it was unmuted automatically. Hello, everyone. Nice to see you all here. Yeah, so thanks for the nice introduction. We always saw some data viz also in the intro slides. And I'm going to talk about engaging visualization design to successfully communicate data. So we're going to talk about data visualization, how to create these charts, figures, graphics, however you want to call them. And maybe I can give you a few hints which colors to use, what tricks you can apply to make them better or more engaging and effective. So a bit of background around myself. So I'm a freelancer as well. That's also why I'm partly here, also working in data visualization. So that's the other reason. But I didn't start as a freelancer. So I got into studying ecology and biology and was in the field and then got into more and more into programming and doing my PhD, which I was doing on disease, ecology, and animal movement. I had to create figures. So I found something called ggplot2, which is a library to create graphics. And I fell in love because the intersection of data, coding, and design was perfect. So I decided to become a freelancer, and I'm still working as a part-time researcher at the Leibniz Institute for Zoo and Wildlife Research here in Berlin, Germany, but most of the time I'm a freelancing data visualization specialist, designer, consultant, instructor. So I'm doing coaching and consulting mostly with code. So as a scientist, I like to start with a definition. There are many definitions out there for data visualization. So I just brought some made up ones from the multiple sources you can find on the internet and somewhere else. So in a very simple way, data visualization can be described as any graphical representation of information and data, which means lots of things around you are likely a data visualization, could be considered to be a data visualization. We could also go a bit more technical. We could say, oh, no, the technical one is the next one. We could go more on the purpose of the data visualization. What's the ultimate goal of that creation? So we can say data visualization helps to amplify cognition or maybe to gain insights, discover, explain, and make decisions. Most likely not all of these in the same one, in the same piece, but it would be good if some of these are the ultimate goals, maybe. You could also say data visualization from a technical perspective converts information and numbers into visual forms as quantifiable features. So this is a very technical speaking, and this likely applies more to financial or scientific graphics, for example. So one example you might think of if we talk about data visualization is something like that. A figure which I took from one publication on GDP and democracy for different countries. And this is a typical scatter plot with a bit of annotation and linear fitting. So that could be considered a data visualization, obviously. But also things like these, which became more and more popular, like dashboards, often, at least if you go for the Google image search, very futuristic looking dashboards with a lot of different chart types, especially radar graphs, for example, down here, or these donut graphics. These are also combined data visualizations which form these kind of dashboards. You could also go back in time, for example, to one of Charles Joseph Minard's works, for example. This is a very old data visualization. It's considered from experts as one or the best statistical piece ever. Mostly the lower parts. So this is a visualization of the troops of Hannibal on the top and the troops of Napoleon at the bottom. And the size of these streams or these lines depict the number of soldiers going from west to east, and then for the lower one also in black back to the west. And this is a lot of information. It's even a map, but also on top of data visualization, quantifying numbers, quantifying information in a visual context. Also, this is a data visualization, or we can call it a data art piece. This is the perpetual plastic submission by Linia Klaus, Sky Moret, and Maurice Stefana, who put together this piece in real life and took created a movie, and obviously also took images and photographs of that, which highlights the plastic in the water bodies in around our globe, and highlighting these numbers by the size of the different colors of the plastics. Or also another data art piece I brought here by Nadi Bremer is called the Patchwork Kingdoms. So here there's a random stochastic element to it, but there's also data behind it. And for example, just a short summary of these pieces, each little building block of these cities depict a country and a school and their internet access. And if it's on the top, like the upper city, then it's connected to the internet. And if it's going downwards, then it's unconnected. So I want to talk about good data visualization design. First of all, like a disclaimer, there's no really like a good versus a bad. There are definitely some recommendations, what not to do or how we can improve data visualizations. I also want to say there's not a single best charts for the one general purpose. So this is more like to take it with a grain of salt, like what are general steps we can use and take and consider to create good and effective data visualizations. So I brought one example here, which is from the article called Yearly Fluctuations in Area of Arctic Covered by Ice by Derek Watkins from the New York Times, which when I asked around for some good data visualization with annotations was mentioned multiple times. I also like it a lot. I shortly want to go into that, why I think this is a good data visualization, and would be also interested if you agree with the people and with me here. A few things I want to highlight here is that there's a lot of use of text. I think this is something important. Here, the reader is guided, and that purpose, it's a news piece, so people are left on their own to explore that visualization. What I especially like is the decent highlighting of the different seasons of winter and summer, for example, and especially the natural scale on the left. So if you look at the y-axis on the very left of the graphic, we see that these are million square kilometers, and I actually have no clue what 18 or 14 square kilometers mean. And the New York Times team was so clever to add some units, which we can maybe get at least a glimpse of, like the size of Canada, the size of Alaska, and the size of California for comparison. And then we also have clever color use. We have different font weights to highlight different things. And here in gray, we have all the years of showing the Arctic ice. And then in blue, light blue color, the more recent years, and in black, the year which this piece is about. So if we want to classify it, there are multiple ways how to classify a data visualization design process, for example. It's also not really strict into boxes. It's more like a gradient, but I like to think of it in 4 steps. The first one would be like information, so the integrity of the data and the final visualization piece. The story, which is the interestingness, the main point, the message of the data visualization. The goal, so is it useful? Is it the right chart type and using the right components to achieve that story goal? And finally, the visual form. So also the beauty, because especially I think nowadays in a very fast living world, it's important to also have some piece of beauty. Of course, not overdoing it. It's still about the data and about the message. But at the same time, I think a bit of effort in terms of design makes a lot of sense to just make people stop and wonder about and make them interested in your graphic. So let's start with the first one, which is information. And kind of the subtitle says, understand your data and be accurate. So this is not about like the design process per se, but also data visualization can help you to understand your data, obviously. So a famous piece is the Data Thesaurus Dozen, which is like a 13 data set collection, which all have the same summary variables. As you can see, there's a dino in there, but also a star and a circle. And this is from a statistical perspective, the reminder that you should maybe visualize your data and not just trust your summary stats. It's a follow-up of a very famous other example, which is called the Anscombe's Quartet. And here it's 4 data sets, which are maybe a bit more realistic. And each of the data set has exactly the same summary statistics with the mean, the standard deviation for the X and the Y axes, and the correlation between those two, but they are visually very distinct. So only one of these would allow for a linear fitting. Others have outliers or have a different shape here. An applied version of this visualize your data example is that one from the graphic is from The Economist, but the study is by Kobach and Spilkin. And they plotted the outcomes of the Russian federal elections from 2000 to 2021. And you can see, if you look closely, that there's a grid emerging in the upper part. And there's like an unusually high number of turnout and vote shares results, which are multiples of 5, so 50, 55, 60%, which is a strong sign of manipulation. So data visualization nowadays is also used to find frauds in data, no matter if governmental election data or also scientific data, for example. So there are now data detectives looking for inconsistencies or irregular patterns in the data. As a reminder, I want to say that our data is never a perfect reflection of the real world. We are likely to forget about it while working on that. That also applies to myself. So we get into our data set, we are excited, we have an idea what to show or what this is about or what might be the exciting novel outcome. But we should always keep in mind that it's a sample of the real world and also reflect that in our data visualization design. What do I mean with that? First of all, as mentioned, it's a subset. So when labeling things, it's not crimes per se, it's reported crimes, for example. That's definitely something I run into as well. Or like if you're catching animals, it's those that you have caught and tracked, but not all the animals. Also, scientists try to generalize, and that's likely also one of the main tasks here, but we should always keep in mind, especially when we talk about the data source, that we are kind of like very explicit about what this is about and where the data is coming from, but also what kind of metric we are showing here. Also, data is collected by humans and then also by machines maybe, or analyzed by machines, and we have guesstimation problems, we have precision and errors. So there are multiple things which can go wrong. So obviously also scanning your data for unrealistic patterns, outliers, and stuff like that is likely a good idea. One example for that, or like for a bias in your data set, which is not an outlier actually, but could kind of come up when you investigate a data set you found somewhere else and you didn't collect yourself likely because it ranges back to 1900, is, for example, looking at disasters like droughts, earthquakes, floodings, or extreme temperatures. And if we would get this data set and we would just plot it, the graph would maybe look like that. And you would say like, oh, wow, that's a fantastic story. Disasters are increasing that much. We are all screwed. That's it. So what's going on here? The thing is that the trends in these numbers are obviously influenced by the accessibility of modern tools to measure these, but also for the reporting. So recently, we are much better in like collecting these data and also reporting these data. We're globally connected, so it's much easier to like build these data sets. So there's likely a data bias, and it's not the disasters which are coming more and more common, but just a larger amount of data. So take, for example, the UFO data or something like that, or comets. That's the same thing. We see a steep increase somewhere in the 80s and towards the 2000s, and that's likely not that these numbers are rising, but that more and more people report it. So if we plot the same graphic on the right end from 1980 onwards, we see that most of these disasters are pretty stable, but for example, floods are going up, or cyclones had also their peaking years. So that's all for now about information. There's much more, of course, but as it's less about the design, I want to go on so we can fill that hour with lots of useful tips and tricks for you, hopefully. So we move on to the story. So once you kind of like are happy with your data, you spend quite some time investigating it and making sure the sources are valid and the data itself as well, you may want to think about your story, which arises already during the exploration, maybe even before you collect the data. So we jump into the data, and one important bit when designing a graphic, and which is often missing, is the message of the graphic. So what's the purpose, what's the audience, what's the general story of this graphic? And I think this is very important to start with, because we have like the process where we just look at the data, but at some point we want to tell a story. And if there's a graphic without a story, it's not really useful and will not be very engaging for people if it's not clear what this is about. There are multiple ways of like putting these into context, like different types of visualization, information, graphics, figures, charts, call it however you wanted to. And the first thing would be like, what type of information do we have? Is it conceptual or measurable? As we're talking about data visualization, we are definitely leaning more to the measurable one. So conceptual would be likely infographics or schemes which show general patterns, but are not backed up by data. But the measurable ones obviously are bar charts, for example, or scatter plots, where we have exact values for the different points and geometries in our chart. The other one would be the purpose. And the purpose traditionally, or at least if I looked around, is often the gradient from exploration to explanation. So do we want to facilitate discovery either for ourselves or for the viewer, or do we want to communicate something? More recently, there might be a more diverse approach to that, or depending on whom you ask, obviously, maybe it's not that recent. I brought a quote from Moritz Stefana here, who said like a common truism about information visualization is that it's primarily about showing the data, but that's not necessarily true for all types of data visualization in all fields. So we have scientific or financial ones where it's obviously important to make decisions to get the exact numbers quantifiable. But there's also fields where we are beyond the neutral display of data, and we wanna kind of tell a story, guide the reader or the viewer. And it doesn't need to be precise necessarily, but maybe it's more about the relationships of numbers. In that context, Alberto Cairo, when I was talking to him, said like he likes to think about it more like a triangle. So as a third component, adding to the explanatory gradient would be the effective one, which is less about discovery and communication, but more about emotion. So on the upper end of this triangle, the priority would be to be efficient and to be effective, and the aim is something functional. While on the other end, we have something which is more about creativity, being artsy, novel, and the response might be more emotional, to like make people interested in a topic, to kind of like bring them joy or maybe even sadness, but less about the functional and the decision-making component. Besides the purpose, it's also very important to think about the audience on multiple layers, actually. So we have the story. So, and depending on the audience, different stories might be interesting for you. So it's very different if you're going to design a visualization for an expert group or for the general public. So if I'm designing a figure for, because I'm a researcher for a scientific journal, for example, I may know that people know what these kind of like metrics are about, or what very specific chart types are for that specific audience. So it's very important with consideration to the story, but also to the later decisions on the labels, the annotation, and also the chart choice to be aware what exact audience you're aiming for. Which also means if you're going to reuse this graphic, you doesn't necessarily should use the same graphic. So a figure I published in a scientific journal, for example, is maybe not the best figure to show then at this general talk where I bring it to the broader audience. The next part would be which variables are meaningful to them. This is related more to the fact that I think, if possible, it's a good idea to work with something people can relate to. So meaningful in the context that people directly know what this value or unit is about. So something as we have seen in the beginning, also helping people to make a sense of how big these numbers are, but also maybe trying to not use complex indices or something like that. There are fields and use cases where you definitely need them, but often, especially to engage people, it might be easier if you kind of like have a low threshold for people to get interested in that and to understand these things. The third part would be what are relevant details to include for your audience. And that's especially as I'm having an academic background, often something people seem to struggle with is that especially if you collected the data yourself, but if you dive into the data and have a long time project, you might get excited about many, many things. So people tend to put too many things into a graphic. And we have different ways and different channels we can use to transport information. And of course, we could like fill all of them, like the positional, but also the color and the shape and things like that. But at some point, it's like fading and making a blurry message and story of your visualization. So you should always keep your main story in focus and maybe think about any additional information that's really needed, or if you can somehow make it less prominent so that the main message still sticks out. Another important bit is how the audience might encounter the visualization. So this is more important to like the medium you're using to show them, but also if it's something the viewer looks at it as themselves, like on their own, or are you going to present that and explain the visualization in detail? Is it part of a report, or is it part of a talk? Is it part of a video, or might it be something you are going to discuss in an internal meeting? So given that, the sizes of the visualization might differ, but also the way how you can present that. If it's in a talk, for example, you could show parts of the visualization step by step. So building it up step by step, explaining different key things. If it's a standalone graphic you share on social media and put into a newspaper, you maybe want to use a lot of additional text to guide the reader and to make more explicit labels that people understand your graphic, because you can't jump in and guide them and tell them, oh, look here, that's actually where you want to look at. And then finally, I hate to say it, but sometimes you don't need a visualization at all. So comparing two numbers, for example, it might be kind of like an idea to use some bubbles, some scaled circles for that. And it's often maybe supportive, but only if there's a big difference, for example, that you see like, oh, wow, this number is much, much bigger. But there are use cases where you maybe don't need a visualization, where you can use a table or just put the numbers, and that might be good enough. And related to the talk versus report visualization, for example, I like to think about like the control we have, and this is a scheme by Andy Kirk I like to reuse here. So we have on the one hand, we have the visualizer control, so the designer, you, when you kind of like creating a data visualization. On the other end, we have the viewer control. And obviously, we don't have that much control over the viewer, and especially if we're not around when the people are looking at it. So we can make sure that the perception and maybe also the interpretation goes right, but the comprehension, what does it mean for the subject looking at that, it's something out of range. And we can try to make it safe that people get most likely what we want to tell them. And that's actually our main goal, I would say. But there's always room for interpretation, obviously, and then for the final meaning for the person. Which brings me directly to the goal. We see this is really a gradual thing. This is already ranging into this next box. And the goal here I define very narrow, like select charts that successfully to tell your story, but it goes a bit beyond that. But if you have your story ready with the honest and accurate data, you need to think about how to present this data. So if you have your story, in the best case, written down and your main variables you want to use for your specific audience, you might want to think about. And also, in the best case, play around with different options. As mentioned in the beginning, there's no such best graphic or chart type for that particular or for that general type of data, but for your particular story, there might be. One example I always bring to these kind of workshops is the article How Maps in the Media Make Us More Negative About Migrants by a team of people. It's a storytelling piece, yeah, feel free to check it out. I think it's a great example. As a disclaimer here, also again, it's about the story and the goal of your data visualization. So it's not about one is better than the other. It's more about how these decisions you put into a design can influence how people read your graphic and what they get out of it. So we see here a map of Europe mostly, a bit of Northern Africa, which shows the number of illegal border crossings. It's a remade map from originally published by Frontex. And we see in the numbers and the size of the arrows, how many people were illegally crossing the borders into Europe on different routes. So in that article, the authors say that already by using the red color and the big size of these arrows, there's like a negative emotion related to that for the people when they look at it. And I'm very likely to agree here. So they did a rework here with the blue color, which is less expressive. It's not blood, it's not anger, it's a bit more calmer. And they use smaller arrows, as small that you hardly can see the small ones for the Eastern route or for the Balkan, the Albanian route, but it has a very different feel already. Also note that the titles have changed. So the title choice, for example, not really related to data. I mean, it should be somehow giving the main outcome or the main purpose and story of your graphic, but choosing words carefully here is also important. Again, there's no right or wrong here, but one says number of illegal border crossings and the other says irregular migrants. So these are different wordings, mostly describing the same things, but with a very different annotation. You could also think about, there should be no errors on that one, so not sure what's going on here. So seems there's somehow overlapping. Sorry for that. It should be just the bubbles on the right map, the blue bubbles, circles. You could also say you replace the arrows and use a different symbol for that, because the arrow is something which is invading. And now, for example, in the Russian-Ukrainian war, we also see these kind of maps where the army troops are going in and out of these countries. So you could also say like, okay, we want to pick something else. We kind of like highlight the route and one of the points where the people are crossing that route instead of showing them moving inside the continent. And then depending on your story, you could also change the full picture and say like, yeah, well, that's just a tiny piece of data, but there's much more about this story. There are people which migrate within the European Union. There are also official immigrants and emigrants. And actually the number of irregular migrants is very small in comparison. Again, this changes the story totally. So it's completely makes sense that Frontex did not use this information, but like zooming out, you also could come up with a completely different story and emotion for the people. You could also say like, yeah, well, maybe I don't need a map and I want to put it in perspective in time to show that like the major peak of irregular migrants arriving has crossed already. And now we have a very, very different story here, with a different goal and different chart type supporting these stories. So now if you think, how should I come up with these? Okay, a map and a bar chart might be not super rare, but there are lots of different chart types you could come up with, and depending on how you kind of like box them and categorize them, there might be hundreds of them, depending on how detailed you want to do this. So one famous thing is this chart suggestion thought starter here. If you Google for, I think, data visualization choice or chart choice helper or something like that, you will come up with this very, very early. And it's a decision tree. So I'm not a big fan of this one, but I nevertheless want to show it as it's one of the main findings if you're searching for these kind of things. And it basically suggests that for different types of data or different classes, you have specific best fit graphics for each of these. That's why I don't like it that much, because it's like basically, oh wow, what can go wrong? I just need to say yes, no. But in general, I think there are much more to this, and I think also we should like sometimes bring the field further and explore and play around and experiment, and not go only back to those which already exist. Also, I spot a few charts here. I don't want to go into detail, which I would not suggest in most cases. So that's another problem with that. Again, there are many ways to group these and to kind of like drive these decisions. So here's just an example of different chart choice helpers. For example, data2viz.com, but also the DataViz project or the visualization universe. They all have different groupings. For example, the data2viz.com also works with a decision tree, but you can see that we don't end up with one specific chart type here, but we have multiple chart types to choose from if we go down these trees. The good thing about most of these, and especially also data2viz, is that if you click on a chart type, it will also give you a short information about it. It will tell you about common mistakes and maybe alternative ways to visualize the data if you want to avoid these common mistakes. And if you are into coding, for example, then you also get often codes to create these graphics in R, Python, D3, or Flourish. That brings me to a few DataViz rules, what people often like to call rules. I like to call principles, or even maybe less strongly recommendations or something like that. There are a few things which the community has agreed on we should not do or should do, but in general, I don't like a strong wording here. One thing which is often discussed, I just saw today in a recent discussion on Twitter about some DataViz design, is rotated tilted labels. And this is from a design perspective and also from a viewer empathy perspective, maybe a good idea to avoid tilted labels to not make them people crack their necks. And this applies to both the labels here below the bars, but also to the label on the y-axis. Also know that in certain circumstances, you will not be allowed to move your y-axis title to the top and use it as a title, for example. But in general, there might be several solutions. For example, making a bit smaller labels, but still readable, or adding line breaks to them and things like that to avoid tilted labels. You could also flip a bar chart here, for example, if we explicitly talking about this one. I also know some people don't like that, but in general, especially in a mobile era where people are consuming lots of data visualization on their smartphone, it's maybe a useful thing if you have a lot of bars that you flip it and then you have enough room for your labels and to add also longer text there. Another quite strict rule, at least for most people, is that bar graphs should start at 0. So here we have a comparison of two different graphics. On the left hand, we see the 0 baseline version. On the right hand, we have a 0 baseline from, well, not a 0 baseline, but a 300 baseline here. This is from the Hands-on Data Visualization book by Jack Doherty and Ilya Iannaku. And the problem with the right-hand side is that we tend to compare the length of the bars, not the endpoint of the bars. And in any case, it will like have an additional effort for the viewer to realize that this y-axis is starting at 300. So I'm definitely convinced that including the 0 baseline usually is the best choice, or in most cases, not saying always, but likely almost always. Because even though you could argue now that people are definitely able to kind of read the axis and get the points of the bars, the first thing people will think here is like, wow, that's a huge differences. And then it will take them a few more seconds or maybe even half a minute to kind of like really do the math, look at all the details while we can avoid all of this extra additional effort and work on the left hand. So another illustration of that by Nathan Yao here. So on the left hand, we have a zero baseline, and then shortly, like step by step, we are moving up the baseline here until the first bar is completely gone. And that's illustrating one of the problems. I basically have full control how big or small this difference should look like to the audience, which is definitely not something we want, that people have this extra effort and also could be misleaded in that regard. One perfect example for looking at wrongly scaled bars is definitely Fox News. So here I brought two versions of the same graphic. I honestly don't know if the correct one is made up or if they kind of like updated it while they were airing. But on the right hand, you see like the truncated axis, and on the left hand, you see the untruncated axis, and then you see that the differences might be still big. I mean, we're talking about 1 million here, but not in relative terms that as big as it's suggested on the right hand. And then, of course, if we're talking about rules or recommendations, we definitely have to talk about pie charts, which are basically a running joke for the database people. And you likely have heard the sentence something like never use a pie chart. I wouldn't phrase it that dramatically, but here I brought to you some examples and some use cases when to use them and maybe when not to use them. So these are 3 different pie charts. They are not the same pie charts. And if I would now ask you to rank the different groups, A, B, C, D, E, for each of these, you might have a hard time, especially if I don't give you any additional tool to measure these. So this would be like the solution to this. So we have one where the values are increasing clockwise, one where it's increasing on the left, decreasing on the right, and then something where all the values are almost the same in the middle. And that's one of the main problems here and one of the major recommendations. Pie charts make sense if you, as here on the left hand, have only a few groups which are very different. So here in that example, the green part is larger than the half, and I directly can see that. It might even work much better than a bar chart because I can easily see what's the half of a circle, and I can see it's way beyond that half. So sometimes they can be very, very powerful, and that's why we still see them. They're especially not powerful if we have, like on the right hand, lots of different categories, and then in the worst case, they're not even sorted. So the general rule is that we sort them clockwise by quantity or by the numbers. So that's why the middle chart is basically also incorrect, as we want the biggest piece of the chart to start at 12 o'clock and then go clockwise. A more scientific perspective, but one of my passionate topics definitely is showing the raw data, the distribution of your data points. And this is an example from the paper by Weisgerber, and they are talking about these so-called dynamite plots, so bar charts, these bar plots with an error, which basically show a summary and the range around that summary value, which is usually the average. And they claim that if you're going to show the raw data, you might be finding more interesting patterns. And you basically not only betraying the viewer or giving them kind of reduced information instead of giving them all the information, but most importantly, at least for me, is that if you're exploring your data yourself and you directly go for the bar graphs, you might miss something which is actually in your data. So looking at other examples, which could all form up the same bars, but have very different meanings if you're going to test them, looking at the p-values, for example, but also just if you look at the raw data, you see that we can have outliers, we can have bimodal groups, or we can have different sample sizes for each of the groups. All of this is hidden if I visualize just the summary statistic here. You can still add the summary statistics if you want to. So, and obviously this chart also only works with a reasonable sample size. So if you have thousands of points, obviously at some point this will break, but there are other alternatives to that. So just kind of like a general advice that looking at the raw data and also maybe presenting it to the audience if it's something interesting and you know, like, okay, it's an unequal sample size and it's a bimodal grouping, for example, that this might even bring a more exciting story and more insights to yourself and the viewer. If you have paired measurements, you might even want to combine them. So here again, the bar graph for these paired measurements for like before and afterwards. But if we draw the points and connect each of these pairs with a line, we can see very different trends. So for the panel B, for example, all of them are increasing, while for C, some are increasing, but some are mostly stable. for D, and C would be like something in all directions. You could also like plot in the lower row the difference between these paired measurements. But I think the slope graphs work also very well if you don't have too many. Speaking of having too many, so this is a visualization I created for one of the challenges I contributed to, which is about the urban population figures. And this is showing almost all the countries around the world, so that's quite a lot, up to 200 almost. And I decided to just plot them as a noise because they're going all upwards here, besides the orange ones, which are only a few, I think 12, which are having a decreasing trend, at least according to the data. And then with the black line, I show the overall average to kind of like highlight, yeah, these are lots of lines going upwards, so the overall trend is very positive with 22% points and more. Talking about distributions, there are also many ways to show distributions, not only like these like clouds of points. You could also make these kind of like histogram look like dot plots. And here I used them in combination with these thin strips, which show then also in addition like a summary of the distribution of the data. So I just want to motivate you to play around and be also a bit creative about what you can combine to show the true data behind your data visualization. Another maybe more unlikely visualization I created together with the Citizens for Europe and IOTO for the Afro Census report. And these kind of visualizations we come up, so we call this a connected dot plot or a dumbbell plot, where you basically compare two groups here, and the line shows the difference between these groups. And there was a high interest because we have a very unequal sample size for each of these responses to show also the sample size. So we have multiple encodings here. We have the axis, which shows the actual numeric value, the percentage of people answering to yes to that or no. And we have the color encoding for different groups here. They are privileged or not. And in addition, the size of the bubbles gives an idea how big the sample size is. So here, the most important information would be like the outcome, like the percentage, which we can easily read from the axis. And then the information about the sample size, it's more like something intuitive to give them like, okay, this is a small group, this is a big group. So here the goal was not that you can say like, these are exactly 13 people responding. It's more about like highlighting that there is a bias. I also want to highlight another, not a chart type actually, but another cool way to show data is which we call small multiples or facets or trellis plots. So on the left hand, you see a graphic by the JP Morgan Chase Institute, and on the right hand, a rework, which I did for a client here. And on the left hand, you see not much because you see that the lines are all going like in a very similar trend, and then suddenly they burst somehow. It's about the percent change in spending before and after the national emergency due to the pandemic. And one of my suggested chart choice changes would be like using a small multiple to really like make clear which of these categories have which trend, and I can easily follow them, and also like to reduce the number of colors, even though the client then asks for colors in the final one as well. We can hardly disentangle some of the colors on the left or see them. Some are very light and have a low contrast here. In addition, I also filled the area to like make easily visible if it's a positive or negative trend. There were also a version where we kind of colored if it's positive or negative, for example. So there are multiple ways to visualize this data. And one suggestion is to think about, especially if you have like multiple groups, to think about having the groups next to each other, the plots next to each other. And if you look closely, you also see that we have slight gray lines in the background, which then show for comparison all the data points that you directly inside one of these small multiples can see how they compare to the other groups. So the Financial Times, for example, makes a lot of use of this. I just brought some examples of small multiples here. So this is a work by the Financial Times on the COVID pandemic as well. We made use of it. So yes, last year we had the honor to publish a graphic piece with the Scientific American in the US about the escalating drought in America, where we kind of show the data, the drought data, weekly drought data for 4 different categories across 20 years and multiple regions. And this is kind of, at least what we came up with, a very good use case to use a small multiple for. You can also come up with spatial small multiples, kind of. So we call these geofacets, for example. And this is a geofacet with maybe a bit unusual graph. We call them moon graphs, which are basically the same idea as a pie chart showing two groups and their share. And the size here also shows the amount of energy produced for Europe. So if you have not recognized that yet, these are a bit unusual to read. And usually we need to put some labels on there or some interactivity that people can hover over and see which country it is, because it's maybe not so intuitive. But at the same time, they give the same space to each of the countries. So they're also kind of like removing the effect of different spatial extensions, which makes it hard, for example, if you use a choropleth map, which are these usual normal maps, which are then colored by some value. Or you could also come up with grid tile maps here, for example. We created one for the German election last year. So on the left hand, you see like the standard choropleth map, this one by the site, but all of them are publishing these. And one problem here is that we have different sizes of these different election districts, but by definition, all these election districts are inhabiting almost the same number of people. So when we think about that people vote, not land, as we learned from the US, it's likely better to show them in a different way. But with the drawback that it's maybe harder to really kind of like spatially refer to these different districts. And on the right hand, you see like a trial of these making a rectangular tile grid map here, where each of these spatial units on the left is translated to an equal sized square, and then we color them by the outcome of the second vote. And we even have an additional gradient to highlight the outcome from the percentages. And finally, and maybe I have to skip a few slides, but I want to talk about the visual form. So to present information in a logical, coherent way. And we also touched upon a few visual things already. So again, sorry for that. It's more like you can think of a gradient. So I'm also moving sometimes bits from one part to the other. But in general, these different steps apply here. And in the visual form, I want to talk more about use of making clean graphs and layouts, but also use of fonts and colors. So in general, declutter your charts. There's an arm missing. Declutter your charts is a general rule, and there are very extreme cases of these, like you should remove everything which is not needed. I'm definitely not on that end, but definitely here in this example, the very grayish multiple grid line and different sizes of the text labels and stuff with 3D effects, graphic, compared to the more clean one, white one with blue bars. I have to admit, definitely these kinds of decluttering should be done. Some people would even argue that you don't need grid lines here, for example. Maybe you don't even need the bars. You could just draw a line for the value. That's a bit of taste, I would say, and how extreme you do the decluttering. But in general, avoid adding too many additional pieces which are not helpful to understanding the graphic, but maybe even distracting the people. Some good examples you will find on the Storytelling with Data homepage and blog. So they have multiple examples. I don't want to go into detail here, where they show, like, especially it's often about grid lines and the level of annotation. You can also see they remove the tilted labels and reduce the amount of text on the x-axis, for example. And they even removed one of the lines. Another example, stacked bar graphics, for example, on the left, a typical Excel graphic with lots of colors, overlapping labels, and lots of information. And on the right hand, at least a more focused and more clean version. I definitely would do a few more twists here, but that's definitely giving you a hint how you could declutter these charts and also bring them, the goal and the story, more into focus of your visualization. In general, I'm a big fan of annotations. I mentioned it with a good example in the beginning. So this is one graphic without annotation. It's about the name Neil, a blog post by Neil Richards. So that's why he picked this name in the US over a period of 100 years. And we can see a steep increase, and then also that it goes down again. But without annotation, this might be interesting and might kind of trigger us to find out what actually happened. But if you want to be explanatory and tell a story for the people, you might want to use annotations here. Some people reply to me that these are too much text, for example, or it's too small, so I'm not going so much into the detail of this particular one. But I think like reading these annotations here makes a lot more sense, especially because most of us are maybe not named Neil and do not know when which Neil was very famous or becoming less famous. To put this in a more general context, two pieces from the Financial Times, and especially John Byrne Murdoch, who said in an interview that text and other annotations add an enormous value for non-chart people. That's one of the key things they do, even as like, one of the key steps they ensure in the end, because this is the entry point. So the title, but also like guiding the people how to read these graphics. While it's a bit lot on with annotation on the left, with these early COVID graphs, I think it's a perfect job on the right, where they kind of like with these arrows and swooshes show what happened during which time period, and also take a closer look at the axis, for example. Again, this is relative. This is kind of like people can refer to that instead of having cryptic numbers here. Just showing you that this is not a recent trend. So this is a visualization from William Playfair from 1786, who made a lot of use of annotations here. So you can see two lines here, the yellow one and the red one. The yellow one shows imports and the red one showing exports. And these lines cross, which is a change in, are they either more exports or imports? And by coloring these areas, they kind of support this. You should look at the difference between those lines, not at the lines in isolation. And then they even put text on the lines and inside these areas, which I think is a wonderful example and shows you that this is nothing we just came up with, and it was always a useful thing to do. Maybe. I also did these kind of things, so a few more examples. One visualization for my Twitter followers back then, where I also gave context why numbers were growing or not so much growing. Or another example from the Financial Times, where they also use color here to highlight specific groups. For here, it's weekends and weekdays. Or even using charts inside charts to guide people. So here we see a heat map from the Financial Times once again. And on the top, you see the color legend, what these different red, orange, and yellow colors mean, but also two tiny grid maps which indicate exactly what columns and what rows would mean. So this is a wonderful use of a metadata visualization, like basically show you, yeah, well, if you go this direction, you will find out that. And if you go this direction, that's telling you something else. Okay, a short ride on typography, and I think I'm going to skip the colors. Sorry for that. So font choice is a different thing, and I could spend hours on that, and definitely you could also spend hours talking about fonts. So I really want to give a few short things here. One is that it's important how or which font you're going to pick. So this is a silly example, which I also am reusing and redesigned. This was brought up quite a while ago. So the famous "I'll be waiting for you" example. And this would be the first version, but we could also go for a different font, which is called COVID-19 here, which gives you this bloody, scary feel. And now the question would be, which would you prefer to wake up to? And it's not really about like, okay, your personal preference, but it's just highlighting that these different choices can spark very different associations and emotions in you. So there might be a gradient. There are lots of fonts available for free or to buy or with your Adobe license or whatever. But depending on which font you choose, the message might become very different. Now you could say like, yeah, well, then I should always use Arial and Times New Roman. That might be fine. And some people do it this way. I personally, as a design person, like to play around with fonts a lot. And it doesn't need to be silly and strictly. But from time to time, yeah, changing different fonts, and also already the decision of using a sans serif or a serif font, for example, makes a very different feel to a graphic if it's either formal or more fun or playful or whatever. Also, keeping it simple might be a good idea, so don't use too many fonts. The same is true of everything else in design mostly. I mean, there are extreme examples where it works, and this is used as one channel to transport information or just to kind of like be novel or scare people away and kind of, or shock them. But usually we want to focus on a few typefaces, styles, and sizes, which means like maybe 1, 2 maybe 3 typefaces for different use cases, also defining very much what for you want to use them. So likely one for headers and one for text or one for annotations. And then also not very many different sizes of these texts and not too many weights, for example. If you're working with numbers, and especially longer numbers, you might want to use a font which uses tabular numbers. Tabular numbers means that they all align nicely here on the right hand. On the left hand, you can see that the font I'm using for this workshop slides, they actually don't have no tabular numbers, so-called proportional numbers, especially the one, for example, is much smaller than all the others. So you see they don't line up. So this is especially important if you have something where the numbers also illustrate that these numbers are much bigger. So if you're looking at tables, for example, this can give you like an idea of a bar graph. So the longer the number, the more people, the more money, the more whatever, and the shorter they are. But in the case of proportional numbers, if all of them would be ones, maybe 10 millions would look smaller than 100,000, 700,000. And one other trick, which is called the 1IL test you can do for your fonts, is typing these 3 letters, so one, a capital I, and a lowercase l, to see if these are different. And on the left hand, you see some very popular examples where at least the I and the L are hardly distinguishable. On the right hand, you see that at least to some degree with some different elements, these are kind of like accessible for everyone. So this might be not always needed, but if you're writing long text and depending on your audience, again, likely something you want to consider. So I'm using, again, the cabinet test, the last one on the left hand, where it's not fulfilling these criteria, but I'm mostly using it here for different contexts and decided it's fine. Okay. Not sure if I quickly should jump into that. We have still 3 minutes left, but I think I move to the wrap up. Not sure how to evaluate it with these people. So there are different color palette choices or color palette types you may want to use. There's sequential you want to use for numerical information if it's ordered. There's diverging ones, which is also for numerical, but you have a midpoint, so you have highlighting both extremes. One article here is this when to use sequential and when to use diverging color scales by Lisa Mood from Data Wrapper, which makes nice use cases. And it's again not wrong or right to use one or the other, but you need to be aware of what you want to show and what's the story of your data. The last one would be qualitative, and this is a note here. The most important here is that you don't use too many colors. So for example, the spending categories example from JP Morgan Chase Institute, they had way too many colors to really allow people to see which color describes which category. Okay, going to skip this. I want to show you a few tools for colorblind simulation, for example. So this is a graphic I did again for one of the challenges, and here it's not an error in my slides or mistake. It's a tool which you can just overlay on any other graphic or any program open on your computer to simulate how it would look like for a colorblind person and to directly test if the colors you have chosen are working. This does not only apply to data visualization design, but also web design and whatever you do with colors. So here's a list of tools you could use. And finally, another cool tool I like to use to pick colors and to directly compare them is the Vis palette by Elijah Meeks and Susie Liu, where you can put in your colors, you can also export them. And then on the upper, you can simulate how these colors would look like for different types of color vision deficiency, for different types of charts, because also it's a matter of if you're using a bar or filled area or small points, text, or lines. And with that, I'm going to shortly wrap up. So data is everywhere and data visualization as well. So we can present data with tables, which might be not so accessible, but there are cool ways to do this, like combining this with a heat map, for example. We have learned that we could represent that with different geometries and different visual forms. This is unfortunately a very bad example of a pie chart. So you see multiple things which go wrong here. I think it's way too much text. It's way too many groups. It's way too many colors. They are not sorted. So pick your favorite mistakes. Or we could show it as a bar graph. Bar graphs are often the best option. It would be a boring world if all would be bar graphs, but that's how it is. Again, the color here maybe not needed. Maybe you want to sort it. It's an ongoing discussion, which is better. Again, depends on the story and the purpose, I'd say. But in any way, data visualization is everywhere, and we make decisions. There's no neutral graphic. but think about like these decluttering rules and try different chart types. Does a table work? Does a pie chart work? Does a bar graph work? Maybe it works better when I sort it, maybe not. Why? Test it with people, ask them, do you understand that, without giving them a lot of context. So just bring them out and get feedback from people. And a nice example for a very clean design. So if you're like, oh, wow, these are now fancy examples, but I'm just doing time series data, you can also do already a lot of styling and good design choices here. So this is one example by the Washington Post. And if you want to have a look at the blog post by Francis Gagnon from the Voila studio, who kind of like wrote a bit about why they liked it. And there's lots of details just with a few tricks with dotted lines and all black, no, and the orange line, but no fancy fonts, no fancy colors and stuff like that. So the 4 steps: information, story, goal, and visual form. And I will keep that up. And thank you very much. And I'm going to take your questions.
Thank you so much, Cedric. I'm just going to hop right into the questions. For anyone who has to hop off now, don't worry. This is all being recorded and it's automatically emailed to you after the webinar finishes. So I am just going to answer from the very beginning. So Ronan was asking, which tools do you use or prefer to make efficient and beautiful data visualization?
Yeah, so as I'm coming from ecology, I was trained in MATLAB as well, but mostly in R. And in R, we can, so that's one programming language I'm using. I can do a bit of Python, but I'm not using it really. So I'm bound to one programming language and use the tools in there. And there's a ggplot library, for example, which is great to do static graphics. So most of my graphics are 100% or to a lot of percentages created in R with ggplot2.
Thank you. Then the next question is, do you have any useful resources you can recommend to anyone to improve their data visualization skills?
Yeah, that's a very general question, so hard. There are lots of resources, so you will find lots of guides and people. I also put together a few on my blog. So in general, this is like a growing field and lots of trends and things. So my recommendation, but I'm also not so much a book person, is to watch the community, to get out there and have a look at there. So there are different communities out there or different channels where you can look for that. So Twitter for me is very helpful because lots of journalists and people are there. If you're more into like artsy data visualization and data art, you maybe want to go to Instagram. I'm using all of these like for inspirational resources. Obviously, also knowing my network and looking at newspaper graphics, for example. So this is more like the general, like, how did they do it? Do I like this graphic? Why do I like it? Just questioning yourself. If you're more searching for a resource, I have a few books I might pull up here. It's a bit random now, but I'm going to pick these 3 here. That would be like the functional art, and there are a few more books by Alberto Cairo, who's a great professor in information graphics and also a very great person. There's another one, a few more of these, also on how you can lie or should not lie with charts. The other one would be Fundamentals of Data Visualization, which is a basic book, but also very comprehensive about things you can do and not do, also about a chart choice and a bit of color, mostly focusing on, what's bad and what's good. It's a bit black and white, but I actually like it. And the last one would be maybe my favorite from these, the Better Data Visualizations book by John Schwabish, who talks through tons of different examples, how you can visualize data that you don't end up with bars all the time or pie charts. So these would be 3 books in the short term, but there are many, many out there.
Perfect. I'm going to answer Laura's question because I think it has a quick answer. What was the name of the tool you used to check for accessibility? I think it was related
to the
color blindness. Yeah.
Yeah, this was a bit fast. I think mine is called color simulation simply. So if you Google for CVD, so color vision deficiency simulator, you will find definitely tools. So there's a homepage called Copeless where you could upload an image, but I like to have these windows you can just move around. I think the other one is called Daltonism if you're a Mac user. So there are multiple of these tools provided. I hope you find it.
Perfect. Florencia is asking, how have you started your career as a freelancer that provides data visualization services? I'm doing my doctoral thesis, but find data visualization more exciting.
Yeah, good question. So yeah, almost the same situation as you had or have currently. So I was considering to do design work before deciding to do life sciences, ecology and stuff like that. So it was basically 50-50. I was always into design. And then for me, it was a perfect match with everything I learned during my studies and PhD to really bring it together. Also to have a different perspective, because like from a programming perspective, you have a different perspective than if you would like learn graphic design. So I like really like this intersection of all these. So when I realized that, I tried to spend as much time as possible on my PhD to get it finished and not to get into database too much. So I also already realized I was spending too much time for my figures, for my thesis and my talks. And then afterwards, I started doing it, so practicing. So on one end, how can I program these parts, but also what works, what doesn't work. I'm kind of learning from others, as mentioned before, learning from your own mistakes. When people say like, yeah, well, I can't read that, and you're like, oh wow, okay. For me, or also I can't understand it because you're into that one and you're kind of designing it, and people you think like, wow, that's the coolest piece ever, and then you just present it to people, and they're like, well, what's this about? So really like practical learning, I think it's very important. Obviously, the books can help you here, but I still think finding a community, maybe first internally where you can share it and get feedback from people, what works and what doesn't. And then I started building a portfolio really with the goal to become independent, at least partly. Let's give it a try. I knew then a few people that this is actually a job that you can do. That's also the other thing. Often people come to me are like, yeah, well, that's so general. You do this for a specific topic. And actually, yeah, I have my topics I like to work with, but it's a very general thing. And often people are not aware that you maybe can just do that besides the analytical part, for example. And yeah, and actually Twitter was a great help, and social media in general, but Twitter. So I was spending quite some time there also to build a network and a followership to get new clients, projects, workshop requests, and stuff like that. This was actually a bit planned, not like a social media strategy. So I didn't get any training for that. It seems that people just like what I have to tell about, but I actually wanted like to put out stuff so people can find it, putting out open access stuff, blog posts and things which attract more people. And lots of people were like, yeah, well, you're just procrastinating on Twitter. Don't lie to yourself. And I definitely was also procrastinating there and doing a lot of random nonsense discussions, but it definitely helped me with the career a lot.
Very cool. Thank you for sharing that.
Yeah.
We have one more question from Johann. Do you recommend knowing a lot of different data visualization tools or focusing on one?
Yeah, tough question. Depends a bit on what you want to do. So, for example, in the context of my scientific work, it's enough to know R because everyone now around us uses R, or I'm the only one working with the code and the others don't even touch it. So then I use whatever I find most convenient. In that context, also the programming approach is cool because you have like reproducibility, transparency about your data, which is like important bits also for me, like to do good, valid research. That's one component. The other component is like, if you want to be the specialist for one thing, so I become a bit of ggplot specialist. I also wondered about if I want to be that or want to be more general, which has their pros and cons, because obviously for like workshops on the tools, you get more booked if you're like more specialist. At the same time, if you have changing teams and you kind of like working with a lot of different companies as an independent data visualization designer, for example, you might end up with different tools. So I'm luckily enough to pick my clients by the tools. So if someone comes like and says like, hey, can you build me a Power BI dashboard? I'm like, no, I can't because I haven't touched it. I also don't want to. Yeah, and some of these tools are pretty easy to learn. So they are the programming ones, but for example, things like Data Wrapper or Raw Graphs or Flourish, these are tools out there. They are straightforward to use. I wouldn't say you really need to learn them to put them on your CV, but definitely make a good choice if you want to do more static graphics for reporting, for example, or if you want to do like scrolly telling interactive pieces, because then you would likely need to learn JavaScript, for example. So it depends a bit also where you want to end up. So I'm still doing a lot of static graphics, but if your plan is, for example, to go to the Washington Post or New York Times, then you likely need to know a bit of JavaScript in these three. Hope that helps.
Thank you, Cedric.
Sure.
I am going to wrap it up right here, I think, unless there are any other burning questions. If anyone does have any questions or wants to reach you, where or how can they reach out to you?
Yeah, it's currently displayed here. So there are all my links also on my blog, also email, most likely on Twitter. So if you're on Twitter, you can just like tweet or write me a personal message. But I have multiple channels, so feel free to reach out.
Perfect. Well, thank you so much. That was really wonderful and really, really refreshing to have also a totally different kind of topic that I found also super interesting.
Thank you.
And this is recorded, like I was saying, so it'll be emailed to everyone. If you're interested in any other events or webinars with us, then please make sure that you're signed up for the Malt newsletter, because that's where you will hear about everything first. I know there are some people tuning in from different locations in Europe. So if you're in the Germany, Austria, or Switzerland area, make sure you're on Malt DE and signed up to the newsletter. And if you're in Spain or tuning in from France, then make sure you're signed up for the newsletters in those regions. Thanks again. Have a wonderful
Perfect.
evening. And we will see you all later.
Yeah. Bye. Thanks, everyone.
Bye. Thank you.